All right, guys, we're getting into matrices again, but we're looking at multiplication of matrices and doing some other stuff a little bit different than what we did last week. You are in the second to last week of new material. So next week will be the last week of new lectures and homework. So you guys are almost there. It's almost summer. You've almost made it. So let's take a look at example 1 here. We've got the following matrices, A, B, and C. Now, before we do anything, I'm going to identify them by their size. So we always identify a matrice by the number of rows, by the number of columns. We don't want to switch that. It's always row and then column. So matrix A has 3 rows and 2 columns. So matrix A is a 3 by 2. Matrix B has 2 rows and 3 columns, so that is a 2 by 3, and then matrix C is 3 by 2, just like A. All right, so there are some rules that we have to apply if we want to multiply matrices and things like that. Okay, so we want to calculate 2A plus C first. So we can take a matrix and we can multiply it by any scalar, any number. So the first thing I'm going to do is I'm just going to multiply matrix A by 2. That means that every single value in matrix A will get multiplied by 2, and then after that we will add matrix C. So here's the deal. 2 times matrix A, that is going to be 2, 0, 6 in the first column, -2, -8, +4 in the second column. So that is 2A. And then to that, we are adding matrix C. Now, the first rule of matrix multiplication, addition, subtraction, if we're adding or subtracting 2 matrices, they have to be the same size. So A and C are both 3 by 2s, so we are allowed to add these 2 things together. The way that we're going to do that is we are going to take the elements in the same positions and add those together or perform whatever operation. In this case, it's addition. And that will be in the same place in our final answer. So 2 plus 4 is 6. And then I'll go over here. -2 plus 6 is 4. 0 plus 1 is 1. -8 plus -3 is -11. 6 minus 1 is 5. And 4 plus 8 is 12. So they will go in the corresponding spots. And that is our final answer. That is 2A plus C. Again, we can only add them when the sizes are exactly the same. All right, next, we are multiplying A times C in this case. So A looks like this. C looks like this. All right, and I'm going to write the size down here. So A is a 3 by 2, and so is C. C is also a 3 by 2. So here's the rule for matrix multiplication. The rule is we can only multiply, we're only allowed to multiply, if when you write out the sizes of the matrix, the inside values are the same. So because 3 and 2 don't match, we cannot multiply these matrices. That's it. There's no answer. Can't multiply A times C because the inside values do not match. Okay, so let's try an example that actually does work. Okay, so we're multiplying B times A. I've written them both out, and I've written their sizes down below. And what we find is that the inner values match, which means we're allowed to multiply B times A. And then what happens is when we look at the outer values, our resulting matrix, our final answer will be a 2 by 2 matrix. So that's helpful in helping us kind of set up where we're going. So I'm going to draw a bunch of lines that'll show the work on how we get to that 2 by 2 matrix, and then I'm going to fill in the blanks with the answers. You can skip this middle step if you guys can do everything in your head. Sometimes it just gets to be a lot of calculations to keep track of at one time. Okay, here's the trick for multiplying matrices. I'm going to draw a picture. You're going to go across and down is kind of the pattern. So across the first matrix, down the columns of the second. So across the rows of the first, down the columns of the second. And then we're going to combine all those things with multiplication and addition. So here's what I am talking about. Okay, first entry of our final answer is going to come from the first row and the first column. Here's what we're going to do. We're going to take 1 times 1 and add to that -2 times 0 and add to that 5 times 3. We'll evaluate that number. That's going to be the first number in our final answer. Okay. Bottom left, that's going to come from the bottom row and the first column. This entry is the bottom row and the first column. Okay, that is 0 times 1 plus 3 times 0 plus 1 times 3. All right, moving on. Upper right, that is going to come from the top row, right column. 1 times -1 plus -2 times -4. So I can write that as -2 times -4 plus 5 times 2. Very last entry, bottom right, comes from the bottom row, right column. 0 times -1 plus 3 times -4 plus 1 times 2. All right, and then we simplify those values and we write our final matrix. Okay, everything is simplified. We get that matrix 16, 3, and then 17, -10 in the other column. That's how we multiply matrices. Okay, so what we're getting at with the multiplication of matrices is a different way of solving a system of equations without using row echelon form. So we talked about row echelon form last week. Now we're going to use a different approach, and that will require us to multiply matrices in order to solve a system of equations. So we also need to know how to find something we call the determinant. So it's easier the smaller the matrix. The larger the matrix, the more complicated the determinant gets. But we're going to start with a 2 by 2, and then we'll get to that last example, which is a 3 by 3. Okay, to get the determinant of a 2 by 2 matrix, you are going to multiply the essentially upper left and bottom right, and then subtract the upper right times the bottom left. So if you draw it out, I think it actually makes a little bit more sense. You multiply A times D, and then you subtract C times B, right? So you're multiplying the diagonals and subtracting them. Okay, remember order of subtraction does matter, but let's evaluate the determinant of A. So we are going to multiply 3 times 4, and then we're going to subtract 5 times 2 from that. So this is 12 minus 10. The determinant of A is 2. And like I said, in just a minute, this is going to allow us to solve a system of equations differently than how we did it last week. We can only find determinants on certain matrices. If the determinant is 0, that means that the matrix has no inverse. So what this helps us do is it helps us essentially find the inverse of our matrix so that we can solve a system of equations. Okay. B is a little bit more complicated. Because B is a 3 by 3 matrix, we can't apply exactly the same equation for a 2 by 2 determinant. So here's what we've got to do. Essentially, we've got to find the determinants of the smaller 2 by 2 matrices that fit in this 3 by 3. Okay, this is where it gets a little bit complicated. First thing I'm going to do is I'm going to cross out the top row and the first column, the left column. Okay, where those two lines intersect, I'm going to take that number 1, and then what I'm going to do is I'm going to find the determinant of the smaller 2 by 2 matrix. So that would be 5 times 0 minus 3 times -1. Okay, I'll simplify all of that in a minute. Next, I'm going to go across. I'm going to cross out the second column, top row. Where those two lines intersect, I am going to take that number, and then I'm going to find the determinant of the smaller 2 by 2 matrix that would be left from these numbers here that we didn't cross out. So that's -1 times 0 minus 3 times 1. All right. Last one then, we've got one more column to cross out. Cross out the top row again. I'm going to take that number, which is 2, and I'm going to find the determinant of the smaller 2 by 2 matrix that has been left. -1 times -1 minus 5 times 1. Okay, we're almost there. The last thing is this. When we follow this pattern, we also follow the pattern with signs. So we start with a positive, negative, positive, right? And if we had a bigger matrix like a 4 by 4 or a 5 by 5, we'd continue that pattern with another negative and then another positive, etc. Okay, so let's evaluate. When we simplify what's inside the bigger set of parentheses, we get 1 times 3 minus 2 times -3 plus 2 times -4. That is 3 plus 6 minus 8, which gives us 1 as our determinant. So that's how we find the determinant of a 3 by 3. Same rules would then apply for bigger sets of matrices as you go. Okay, the very last thing we need before we can combine everything together to solve a system of equations is the inverse of a matrix. So in order to find the inverse of a matrix, we find the determinant, then we take the reciprocal of the determinant and what we call the adjugate of the matrix. You might hear it as the adjoint of the matrix. The adjugate of the matrix, multiply those things together, and that is the inverse. Now, it becomes so complicated to take the inverse of any matrix bigger than a 2 by 2. So the last example on the notes today, we're actually going to go back to row echelon form because anything bigger than a 2 by 2 is just way more complicated to do it this way. So we're going to stick with 2 by 2 matrices and finding those inverses by hand. Okay, so we want to find the inverse of this matrix. So the first thing we need to do is find its determinant. So the determinant of A is equal to 3 times 4 minus 5 times 2. So the determinant for A is 2. And then we are going to find the inverse of A by taking the reciprocal of that determinant and multiplying it by what we call the adjugate matrix. So here's how we find the adjugate matrix. I'm going to call it that. So the adjugate of A. We are going to switch A and D. So we're going to switch the values in the upper left and bottom right. So that is going to be 4 and then 3. And then we're going to take the two values in the upper right and bottom left and make them negative. So that is -2, -5. That is the adjugate matrix for A. That is what makes solving something more than a 2 by 2 matrix just incredibly impossible. Finding the inverse of a 3 by 3 is just, the number of steps is insane. So we're not going to do that. We're going to stick with 2 by 2s. All right, so the inverse of A then is the reciprocal of the determinant times this adjugate matrix. What we get is 2, -1, -5 halves, and 3 halves. That is the inverse of A. We're going to use that in the next video in order to help us actually solve a system of equations.